This is a very simple introduction with a lot of oversimplifications, but it's here to give you the main idea. Some molecules are sturdy. Some molecules break a little bit when you get them wet. And some, like the Wicked Witch of the West, completely go to pieces if you get them wet. Acids and bases are the things that tend to fall apart. Strong acids and bases are the ones that completely come apart, where HCl just becomes H plus, Cl minus, H plus, Cl minus. They're all separate pieces. A weak acid like HF, most of the HFs stay together, but every once in a while you get an H plus here and an F minus there, an H plus here and F minus there. So some of the molecules are breaking up. Not very many, but some. Same thing with bases. A base is something that either can drop an OH or can create an OH by ripping a hydrogen off of a water molecule. I mean, you end up with an OH minus either way. So NaOH is a strong base, and so it completely breaks up. Na plus, OH minus, Na plus, OH minus. Strong means it breaks up. Weak base means it only breaks up a little. So NH3, ammonia, you have NH3, 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 and then a little bit of NH4 plus and OH minus, because basically the ammonia just stole a hydrogen off of a water molecule. So that makes it a weak base. Now let's just look at regular water for a minute. Regular water itself can break up a little bit. Not very much. You have mostly H2O molecules, but you'll have H plus and OH minus once in a while. 1 in 10 to the 7th, 10 million molecules of water will be broken at any given time. And that 1 in 10 to the 7 means the pH is 7. Water is what we call neutral. A low pH has more H pluses in it than OH minuses. Just a couple of OH minuses here and lots of H plus. A high pH has lots of OH minuses and very few H pluses. The more H pluses you have, the fewer OH minuses you have. How does that work? Well, if you try to add a little bit more OH minus, what's going to happen is one of these hydrogens is going to pounce and you're going to get a water molecule. And so having lots of H pluses means OH minus does not have a good survival rate. High pH means that the H plus concentration is very low. You have lots of OH minuses, so an H plus can't really last very long before it runs into an OH minus. So that's why high H plus concentration means low OH minus concentration, and vice versa. Based on water, we can tell what the product is, because if 1 in 10 to the 7th molecules break, then the H pluses 10 to the minus 7 concentration, and the OH minus 10 to the minus 7 concentration means the product is always 10 to the minus 14. And that's why our pH scale runs from 0 to 14 roughly. So that's acids, bases, and pH.